My name is Gretchen Valito, and I'm chair of the Juniper Group Sierra Club here in Bend. And we have several Sierra Club people, many Sierra Club people. I wanted to first give a shout out to Richard Salarius, who wanted to say hi to Chad. Richard, let's see, where are you? You can, let me see. Okay, so I'm gonna unmute.
Thanks, Gretchen. We've waved.
You want to say hi?
Hi, Richard. Great to see you.
Hi, Chad. Good to have you. And
Good that you're writing books.
keep on trucking with the board. It needs help.
I will. Thank you.
Thank you, Richard. Richard was former head of the Sierra Club many years ago, but he's now in Oregon, and we are lucky to have him on our chapter XCOM. So very nice. Let's see if okay, people are still coming by, but I think we're going to go ahead and start. I will just read a little intro so you understand a little bit more about what Chad's background is. He is now director and principal ecologist of the John Muir Project of the Earth Island Institute, which he founded in 1996. It's dedicated to the ecological management of federal public forest lands with the goal to ensure that they are managed to provide ecological conditions that support and restore the native biodiversity, which have been severely degraded and damaged by decades of commercial logging and suppression of wildland fires. And then just to kind of go back to the beginning, he hiked the 2,700-mile Pacific Crest Trail with his older brother in 1989. And that experience inspired him to become involved in national forest protection. He witnessed firsthand the devastation caused by rampant commercial logging on our national forests in California, Oregon, and Washington. And that awakened his passion to protect our magnificent forests and their ecosystems. After the PCT hike, Chad finished his BS degree from UCLA, then attended law school here at the University of Oregon. And that is when he began his career advocating for the Native Forest Council and volunteering for the Sierra Club. He earned his law degree in 1995 and started the John Muir Project shortly after. Dr. Hanson earned his PhD in ecology from the University of California, Davis in 2007, focusing on forest and fire ecology and rare wildlife species that depend on post-fire habitat in the West. He is the author of an extensive array of scientific research papers on forest and fire ecology, on wildlife's use of burned forests, and fire history and trends. He was recently reelected to the Sierra Club's National Board of Directors for his second term. Congratulations. All right, Dr. Hanson, let's go debunk the myths.
All right, thank you.
Yes.
Well, thanks everyone for joining tonight, and thank you, Gretchen, for that introduction. Appreciate it. So I'm going to share my screen here, and hopefully that'll work out just fine. All right, can everyone see that okay? There's usually a little bit of a delay.
It's fine.
Coming through. Okay, good. All right, good deal. So I'm going to talk tonight about a couple of the key myths about forest fires that are getting in the way of key progress that we need to make on terms of biodiversity conservation and also in terms of climate change mitigation. And these are two of the central myths that I discussed in my new book, which is called Smokescreen, Debunking Wildfire Myths to Save Our Forests and Our Climate. And all right, so there's a strong consensus now among scientists that we have to move beyond fossil fuels to overcome the climate crisis, but that's not nearly enough. We also have to draw down atmospheric carbon. And the best and most environmentally positive and most effective way to do that is by protecting natural ecosystems, especially those that store a lot of carbon like forests. And so it's a two-part solution. It's really about moving away from fossil fuels and protecting forests. And there was a letter signed by over 200 climate scientists and ecologists that was sent to Congress last year, myself included, that made these key points. However, there are some key myths, some really insidious myths that are getting in the way of progress that we need to make in terms of forest protection for climate change mitigation. So I'm going to talk about a couple of those. But first, just from a contextual standpoint, forest protection can be up to half of our needed climate change mitigation globally. And in fact, the US plays a really central role in this because it may surprise many to learn that we do more logging in the US than in any other country on Earth, including Brazil. And that means because most of the carbon in trees that are removed from the forest through logging, most of that carbon goes into the atmosphere almost immediately. That the US is also the biggest global culprit in terms of carbon emissions from logging. Logging in the US annually is actually emits more carbon than the residential and commercial sectors combined in this country. So it's a huge source of carbon emissions. So we need to protect our forests. We need to get the Forest Service out of the commercial logging business, for example, but also expand protected public lands, especially in regions that don't have as much public land like the Southeast and Northeast. But we need to get away from and get beyond some of these myths. First one I'm going to talk about is the overgrown forest myth. And this is this notion, I'm sure we've heard it many, many times, that our forests are too dense, there's too many trees, there's too much carbon, too much biomass in the forests. And usually the blame is placed on environmentalists and environmental groups like the Sierra Club and environmental laws that sometimes restrict logging operations. And the argument is made that because our forests are overgrown, that's why they're burning too intensely. They're burning more intensely in fires, supposedly because there's simply too much biomass in the forest. That's the narrative. I'm going to talk about that a little bit and sort of deconstruct it. So the first thing to realize about that is that in every forested region of the United States, we actually have less carbon, in most cases substantially less carbon, than our forests naturally would store in terms of their biological carbon storage potential. And the reason for that, of course, is decades of removal of carbon through logging. So the idea that our forests have too much biomass in them or too much carbon in them is absolute mythology. In fact, it's the opposite. Our forests have far less carbon. Now, what that means is that we have huge climate change mitigation potential in every forested region of the country: the Pacific Northwest, California, Northern Rockies, Southwest, Southeast, and Northeast. Every region of the country, upper Midwest. We have huge climate change mitigation potential because our forests could store a lot more carbon than they currently are storing because of all those decades of logging. Interestingly, when you do have denser forests that have a lot of biomass, a lot of carbon, they do not tend to burn more intensely. So it seems intuitively obvious to a lot of people that a denser forest is going to have more fuel, right? That's the thinking. But the reality is that this field of forest and fire ecology and climate change mitigation, it's kind of like opposite world. So many of the things emerging from the scientific evidence are the opposite of what you might think superficially, and this is one of them. Turns out denser forests have higher canopy cover and therefore more cooling shade of the canopy cover, and that keeps the forest floor more moist deep into the fire season when everything else is drying out. And that has a mitigating effect on fire. In addition, forests that are denser have more tree stems, and that actually creates sort of a windbreak effect against the winds that drive the flames in a fire. And so, it may seem counterintuitive, but there's stacks of scientific studies. I've done research on this, and so have many others, that show that forests with more biomass, more carbon, denser forests, tend to burn less intensely most of the time. And this graph here is just from one of those studies. There are many. This is Zalden Dunn 2018. It just shows as biomass goes up, fire intensity is actually lower. Now, interestingly, in a related fashion, forests that haven't burned in the longest period of time also do not burn more intensely. And this is one of those key aspects of this overgrown forest myth, is that because we've suppressed fires, the forests are too dense, there's too much fuel has accumulated, that's what we've been told. And therefore, forests, if they haven't burned in a long time, we simply can't allow that natural lightning strike to burn and restore fire in those forests, because supposedly, if they haven't burned in too long, they'll burn far too intensely. They'll burn almost exclusively at high severity. That's what we're being told. And this issue is really interesting. I've actually contributed multiple scientific studies to this in the peer-reviewed literature, so have other scientists, and we've all found the same thing. Forests that haven't burned in the longest period of time burn mostly at low and moderate intensity. They do not burn mostly at high intensity. And in fact, they do not burn more intensely than forests that have burned more recently. Again, seemingly counterintuitive, but it's because of these countervailing factors that I mentioned before. High canopy cover, more cooling shade of the forest canopy on the forest floor. Basically, denser forests, forests that haven't burned in a long time, oftentimes, forests that have more environmental protections, they tend to have a cooler, shadier microclimate. Now, the other thing that's key, that's important to understand, is that forest fires are driven mostly by weather and climate factors, not by the density of the forest. However, forest density is not totally irrelevant. It just doesn't work in the way that most people assume. So the assumption is, and this is what we're hearing from a lot of folks in Congress right now, most of them Republicans, but some, unfortunately, some are Democrats, that if we just remove a lot of trees from the forest through commercial thinning operations or other logging operations that they sort of euphemistically call fuel reduction, if we just remove more trees from the forest, that will curb fires. It'll make them burn less intensely. We actually conducted the largest scientific analysis ever conducted on this question, my colleagues and I. We published that in 2016 in the journal Ecosphere. The study is Bradley et al. 2016. What we found are two key things. Number one, weather and climate, and therefore climate change, are the main drivers of forest fire behavior. However, the secondary factor was logging and levels of forest protection. Forests with the fewest environmental protections and the most logging burn the most intensely. And forests with more environmental protections and less or no logging burn the least intensely, even in the same forest types. So we controlled for forest type. And oftentimes when these fires burn more intensely through those logged areas, they're burning faster and hotter toward towns and putting people at risk. And interestingly, there's a lot of research that shows that it's not just clear cutting or logging of big old trees, it's also commercial thinning, which logs and removes many small trees, but also many mature trees as well. And it typically increases fire intensity. Now, not always, because fires are always variable. You can always find a stand that was commercially thinned and burned at lower intensity. And certainly the Forest Service and the logging industry point to those examples every chance they get. It's important to understand that those are exceptions, not the majority. Most of the time, commercial thinned areas burn hotter. And I'm actually doing research on this on the two biggest fires in the Sierra Nevada last year. And I'm finding the same thing. The commercially thinned areas burn more intensely than the unlogged areas. And these are the findings of my initial findings of my study. This is on the Creek Fire, burned 380,000 acres last year. Salvage logged areas where they logged the dead trees under the guise of fuel reduction, those areas burned more intensely. Private lands where logging was very intense, burned more intensely. Commercial federal lands thinning areas burned more intensely. And the areas that burned the lowest intensities were areas on federal lands with no logging in any recent decades, or no logging ever because they're in protected areas. And in fact, areas with high levels of dead trees burned very low intensity, had some of the lowest levels of fire intensity. So the notion that dead trees are driving fire intensity, that's also not true. And in fact, this is my analysis on the Creek Fire with regard to snag density. And the forests with the highest levels of tree mortality prior to the fire from the previous drought actually had some of the lowest levels of fire severity. Now, the other one I'm going to talk about briefly is the catastrophic wildfire myth. And this is this idea that if a fire is large, if it burns hot in certain areas, if you get these larger high intensity fire patches, that it'll sterilize the soil and nothing will grow. We've heard this many, many times in different ways, and that it'll destroy wildlife habitat. So I'll deconstruct that one too. First of all, even the biggest fires, they're mostly low and moderate intensity. This is a fire intensity map of the Rim Fire, 257,000 acres, burned in 2013 in the Sierra Nevada. And I've done numerous scientific studies in this fire. Now, of course, when they make these fire intensity maps, they always put high intensity in bright, shocking red. And so it looks like a larger percentage of the fire than it really is. High intensity fire is the red here in this map, and it's only 19.9% of the fire, 20% basically. Therefore, 80% is low and moderate, which is the green, the light green, the dark green, and the yellow. And those are areas, of course, where most trees survive, especially the larger overstory trees. And so what does it mean in these areas that do burn at high intensity, those patches where fire really does burn hot, that 20% in this fire, and 12% in the Wallow fire of 2011, for example, even larger fire, 565,000 acres. But again, like even the biggest fires, they're mostly low and moderate intensity most of the time. You can always find some exceptions, but they're pretty rare. So historically, even in the frequent fire forest types, like ponderosa pine and mixed conifer, there was always a mix of fire intensity. It was natural to have 20 or 35%, sometimes 40% of the fire burn at high intensity. It could be as low as 10 or 15%, but on average at the landscape scale, it was usually in that 20 to 35% range that was high intensity fire. And so it's important to understand we actually have less fire of all intensities now than we did historically prior to fire suppression. And I'll get to that more in just a minute. But right now I'm going to talk about some of the biodiversity. You know, high intensity fire patches create what we call snag forest habitat. And snag forest habitat, it turns out, is not destroyed, it's actually created by fire. And it's incredibly ecologically rich. It's comparable to old growth forest in terms of native biodiversity and wildlife abundance. And this is just a picture of a few of the denizens of snag forest. The blackback woodpecker is there at the top. They depend on fire-killed trees, a very large abundance of them, because they eat the larvae of wood-boring beetles, which in turn are native species that depend on fire-killed trees for reproduction. And the woodpeckers eat thousands of these beetle larvae every single year, and they excavate nest cavities in the dead trees, which they need because they're softer than live trees. And they create new ones every single year, several actually per year, and they pick the one they like the best. And all the ones they create that they don't use are available for all the other cavity nesting species in the forest that need cavities to survive and raise their young, but can't make their own, like bluebirds, nuthatches, flying squirrels, chipmunks, dozens of bird and small mammal species. Even other woodpeckers, like flickers, use the former blackback woodpecker cavities, as well as cavities of other woodpecker species. And so as a result, biodiversity and wildlife abundance tends to go up in these high intensity fire patches. It doesn't go down. These areas are not destroyed or lost by fire. They're actually, fire is a rejuvenating force. It's something that actually enhances biodiversity so long as these areas are not subjected to post-fire logging, which is incredibly destructive. And so as I mentioned a moment ago, we actually have this broad consensus of this among scientists. Apologies for the background noise there. We actually have significantly less fire in our forests now than we had historically. And scientists debate how much less, but everyone agrees we have quite a bit less. And so we don't want too much fire, but we need to acknowledge right now we're still in a deficit situation in our forests. Now, interestingly, here's one of the other aspects of the catastrophic wildfire myth. And we've probably heard this, folks on the call many times, this idea that when fires burn hot, the trees are just consumed and all the carbon goes into the atmosphere. Now, in reality, only about 3% of the carbon in trees is actually consumed, even in a high intensity fire patch. On average, even in the biggest fires, it's only 1 or 2% of the tree carbon is consumed, sometimes a lot less than that, just a fraction of 1%. And of course, fire cycles nutrients, creates a nutrient-rich bed of mineral ash that spurs and enhances the growth of the forest over time, starting in the first year post-fire and then accelerating every year after that. And that allows the forest to pull more CO2 out of the atmosphere, increasingly more in every year post-fire. So whatever carbon is released, it starts getting recouped very quickly after a fire. And of course, what we see in these, even in these large high intensity fire patches, is abundant natural conifer regeneration. This is in the middle of the large high intensity fire patch in the Rim Fire. This is a large high intensity fire patch in the Star Fire of 2001 in the Sierra Nevada. This is at 12 years post-fire, this picture. And you see just this amazing regeneration. Of course, that's all carbon being pulled out of the atmosphere and being stored and sequestered in the growing forest. This is me in the rim fire last year. This natural regeneration, it's already in some places 12 feet tall. It just, that was 7 years post-fire. It's remarkable. And so as a consequence, forests become a carbon sink again, typically within just several years after even a large fire, because of the nutrient cycling and all the post-fire regrowth. And it's not just conifers, of course, it's shrubs, it's oaks, it's dogwoods, it's in various places, aspen and other species. And it's important to understand our forests are still a significant carbon sink in every region of the country. They're a significant carbon sink, but they could be a much bigger carbon sink. In other words, they could remove a lot more carbon from the atmosphere if we protected them from logging. Now, one of the key threats is post-fire logging. This is an area in the rim fire where the snag forest habitat was clear cut to feed a biomass plant down in the Central Valley of California, basically incinerating the fire-killed trees for kilowatts as if they're big sticks of coal. We call this clear cuts for kilowatts. And it's a climate change nightmare because not only is the post-fire logging destroying the naturally regenerating forest and removing the young regenerating stand, but they're removing the dead trees and they're incinerating all of that. And all of that carbon, 100% of it is going into the atmosphere. And of course, because of the soil damage and the nutrient removal, many of these areas remain bare ground and invasive grasslands for many years after. Even if they plant, oftentimes the trees die. Commercial thinning. People think of that as a fairly light touch thing, but in most cases, it's a pretty intensive industrial logging operation. This is an area that was commercially thinned, and you see that there's widely spaced live trees. That's all that was left. Most of the biomass in this forest was removed. The down logs, the dead trees, most of the live trees. And in fact, most of what defines a forest ecosystem was removed from the forest. And that's pretty common in these commercial thinning operations. Now, as I mentioned, logging is a huge source of carbon emissions. And in fact, logging in US forests emits 10 times more carbon annually than fire and tree mortality from native beetles combined. So this is the carbon bomb, logging. It's not fire and it's not beetles. So what does this all mean? So, beware, be careful of, and be wary of legislation claiming to promote forest health, fuel reduction, or restoration. These have become buzzwords for commercial logging, euphemisms to mask what's really happening. It's just the same logging oftentimes that we saw in the 1970s and 1980s, including clear cutting. And support legislation to protect public lands from logging, and also to end logging subsidies and to acquire more lands from willing sellers, forest lands, so we can maximize our climate change mitigation. And if you want more information, of course, you can check out my new book, Smokescreen. I've got the link there, and you can get that on both Amazon and bookshop.com, and as well as from the publisher, University Press, Kentucky. It's called Smokescreen, Debunking Wildfire Myths to Save Our Forests and Our Climate. And I'll stop sharing now and be happy to answer any questions.
Thank you. I wanted to mention that I ordered your book for the library today.
Great.
Let's see if we have some questions in the chat or comments. Marina Ritchie says, this is so amazing. We must make sure Merkley and Wyden watch this, our senators from Oregon. And I couldn't agree more, because they're being duplicitous about some of the logging and thinning. So we're very concerned about that. So let's see, if you want to ask another question, maybe you can put it in the chat, or I can, let's see, I think I can make you unmute. Let's see.
I see a couple of questions in the chat. I'd be happy to respond to some of them.
Okay, great.
All right. So I see one right here. Is there a correlation between fire suppression and higher levels of tree beetle deaths? That's a great question. And again, everyone, I apologize for the background noise. I can't avoid it. I was actually doing a site visit of some snag forest habitat in the San Jacinto Mountains, and I'm just on my way back, but wasn't able to get home in time for the presentation. So I'm at a Starbucks down the hill from the fire area I was just touring. But in answer to the question, it's really interesting. You would think this is another one of those things that seems intuitively obvious. You would think that stands that are denser would have more competition between trees for water, for nutrients. And in a sense, there is more competition. However, there are also countervailing factors. In certain ways, proximity from one tree to another actually gives trees advantages and benefits, in part because of the mycorrhizal fungi networks in the soil. And so as a consequence, denser forests do not tend to be more vulnerable to tree mortality during droughts. They don't tend to have higher levels of tree mortality. In fact, they oftentimes have lower levels. These are forests with more trees and higher biomass and more basal area, however you measure it. Forests that you would assume, hypothetically, would have higher competition actually have typically lower levels of tree mortality because, again, forests are just more complicated than that. Yeah, and I see another question here. Is there an alternative to prescribed burns? It seems like this is awful for our air quality. Great question. So prescribed burns are something that, there's a time and place for them. There are certain contexts where it can be useful, especially, for example, to provide an additional buffer to protect a community from wildfire. And so there's a community safety aspect to this where it can be useful. However, in the wildlands, prescribed fire cannot mimic natural mixed intensity fire, and it doesn't mimic it because prescribed fire is usually done outside of natural fire season. And the goal is typically to generate kind of homogeneous low intensity fire. And the fact is that many species in the forest have evolved to depend on high intensity fire. Some like low intensity, some like moderate, some like high. And so if you apply homogeneous low intensity fire across the forest, then many species will not get what they need, and many of them are already declining, and we can't have that. As well, the thing is, prescribed fire doesn't stop wildland fire. It will actually modify fire behavior temporarily for a relatively brief period of time, sometimes as little as only 2 or 3 years, sometimes as much as 7 or 8 years, or 9, but it doesn't stop wildland fires, and its effect on modifying fire behavior is fairly transitory, it's fairly fleeting. And so you get the smoke from prescribed burning, and on top of that, you get the smoke from wildland fire. Not only that, but instead of having smoke during fire season only, you get smoke almost all year round because they're burning before fire season with prescribed burns, then you have wildfire season, and then they're burning after the wildfire season with prescribed burns. It's not a solution. The solution is to allow more lightning strikes to burn and create natural mixed intensity fires in our more remote forests where it's not close to a town. Let's see. So, see another question here. I see a great question about, let's see, quite a bunch of great questions. Let me just try to take them in turn. Okay, so question here, can I talk a little bit more about wildfires in summer of 2020 in Oregon and how it's related to unmanaged, or how it's related to management of forests? Okay, so I'm gonna talk briefly about the 2020 fires in both Oregon and California. A lot of folks are starting to look at this. I'm one of the scientists looking at it. Also different forest protection groups have looked at it. And the areas that burned the most intensely were oftentimes the areas that had the most intensive logging history. In Oregon, a lot of it was past clear cutting, but it wasn't limited to clear cutting. A lot of these areas had also been commercially thinned on both public lands and private lands. Protected forests, unlogged forests, didn't tend to burn as intensely overall. That was the same in California. And again, you can always find at the stand scale exceptions to this, but at the fire scale, any unbiased analysis is finding, by and large, the logged areas are burning more intensely. So logging is definitely a factor. Let's see. So I also see a question here. Someone says it's the first time they've seen a presentation noting that thinning oftentimes increases fire intensity. And oftentimes thinning is touted as a way to prevent crown fire or to reduce fire intensity. It's interesting, and this is true in lots of different forests. This question's been looked at in dry forests. It's been looked at in wet forests. It's been looked at in forests in the Rocky Mountains and lodgepole pine. It's been looked at in the eucalypt forests of southeastern Australia. And it turns out that there's pretty broadly a consensus that's developing that the more trees you remove from the forest, the hotter and faster fires typically burn on average. Again, you can always find an exception at the stand scale. But on average, it's creating hotter, drier, windier conditions. And it also spreads invasive combustible grasses, typically the logging operations. So it's really important. There's been a marketing campaign essentially from the Forest Service and the logging industry to promote thinning as if it's a consistent, reliable way to reduce fire intensity or stop fires. And that is mythology. It does not do that. It does not stop fires. And sometimes it will burn at lower intensity. Oftentimes it does the opposite and burns at higher intensity. So another question, someone asked, what's the most successful strategy to preserve forest stands from logging? Basically, it's to outlaw logging, whether through regulatory measures or through statutes, new laws in Congress or in state legislatures when you're talking about private or state lands. We need new legislation and new regulations, all of it, to protect forests from logging. That's really what it comes down to. Let's see. Also, question, are a lot of these discoveries recent? Yes, actually, that's true. A lot of this information is in the last 10, 15 years. And in fact, a lot of it's in the last 5 or 10 years. We've had just a revolution in scientific understanding about forests and fire in the last decade. Let's see, question, is there a problem in the understory? Does clearing that out help prevent fires? No, it really doesn't. It doesn't prevent fires, and oftentimes the measures that are designed, they say, well, we'll reduce understory trees and that's going to stop fires or reduce their intensity. Those are the areas that I'm talking about, these commercially thinned areas, where they say they're mostly removing understory trees. Of course, they remove a lot of mature trees too. But these areas are oftentimes burning at higher intensities because, again, it's changing the microclimate of the forest. It's creating hotter, drier, windier conditions. It's creating combustible logging slash debris. It's spreading combustible invasive grasses, and it's reducing the windbreak effect of the forest. And so in most cases, the fires burn at similar or higher levels of intensity. Let's see, a question here. Senator Wyden's doing a town hall on the Americans Jobs Plan, and it includes civilian climate corps that would pay you to do restoration and fire mitigation. Yeah, those are euphemisms for logging. What Senator Wyden is proposing would take us in the wrong direction completely. Senator Merkley has been making noises about this too, and they're on the wrong track completely. They're promoting the idea that if we remove more trees from the forest, and if we massively increase taxpayer subsidies for logging on federal lands, if we call it thinning and fuel reduction, that's going to curb fires, it'll stop fires. What they're telling you is not consistent with the current state of scientific knowledge. It will not stop fires. It will often make them burn more intensely. And in addition, thinning actually it causes a large net increase in carbon emissions and a large net reduction in forest carbon storage. So from a climate change standpoint, thinning is a really bad idea. And there's great research on that from Tara Hudeberg and Bev Law and Mark Harmon and others. Let's see, so question about, so really beware what Senator Wyden and Senator Merkley are proposing would take us in the wrong direction, exactly the opposite direction from where we need to go. What we need to do is focus our resources on protecting communities from wildfire. We have to protect communities. The only effective way to do that is to provide resources to help homeowners make their homes more fire safe, and also do defensible space pruning within 100 feet of homes. That's the only effective way to do it. Beyond 100 feet of homes, there's no additional benefit of vegetation management to protect homes from wildfire. So it really is about the homes. And if politicians are concerned about communities, especially after some of the losses we've seen in Oregon and California in recent years, they need to focus resources on homes, not on more backcountry logging under the guise of thinning or fuel reduction. someone asked, can you quantify the impact of forest burning on greenhouse gases, climate overall, versus the impact of logging activities that follow? Yeah, so I had a slide on this, but I'll just reiterate it briefly. Basically, logging in US forests emits 10 times more carbon than wildfires and beetles, native bark beetles combined. So it's overwhelmingly the main source of carbon emissions. And the reason for that is simple. When fire burns in a forest, even a really big hot fire, it consumes very little of the tree carbon is actually consumed. And of course, that's where most of the carbon is in the forest. Above ground is the trees. The duff and litter has higher levels of consumption, of course, but that's much less carbon is in the duff and litter relative to the trees. And so the carbon emitted is much, much less in forest fires than all of the models are telling the public. And not only that, but the models, none of them take into account post-fire regrowth and therefore the uptake of carbon. And so as a consequence of that, forest fires are not nearly as large a source of carbon as we've been led to believe. And that carbon that's emitted is recouped very quickly because of post-fire regrowth. Whereas logging removes oftentimes 30, 40, 50% of the carbon, like in a commercial thinning operation. And most of that goes into the atmosphere because about a third of the tree, oftentimes, up to a third of the tree, the carbon in a tree is in the branches and treetops, and that's incinerated as logging slash debris, oftentimes at biomass plants. And then the log is taken to the mill, and only a portion of the tree ends up as lumber. The rest is mill residue, which gets incinerated at the logging mill as what they call hog fuel. So in reality, logging in the 21st century is mostly about dirty fuel. In a way, lumber is actually just a secondary byproduct. In a sense, oftentimes most of the carbon in a tree is ending up incinerated for energy. And it's a really dirty form of energy. In fact, incinerating trees for energy produces more CO2 than burning coal for equal energy produced. It's actually worse than coal. Let's see. So, okay. So another question about lumber demand, or what do we do, right? The answer is this. Sorry about that background noise. What the scientist letter last year said to Congress, a letter from over 200 scientists, is that we need to start shifting away from wood consumption, just in the same way that we're shifting away from fossil fuel consumption. It's not going to happen overnight. It's going to take decades. It doesn't mean we're not going to use any wood products at all in the future, but it means we need to use a lot less, which means we need to reduce our consumption for the wood products we do use, smaller houses, don't support unnecessary building projects, but also it means we need to shift to non-wood alternatives for paper, for building materials, and there's lots of them. There's tree-free paper, of course. There's lots of non-wood building materials. There's even hempcrete blocks for housing construction now that's structural, that's load-bearing. There's at least 2 different companies that are doing that in North America alone, and there will be more in the future. So we need to start embracing these things, build smaller houses and build out of non-wood, especially materials that don't burn in wildfires, which wood does. And so we need to begin this shift, and that's essential because we're not going to get to the place where our forests can absorb more CO2 if we're just doing the same levels of logging, or if we're increasing logging, God forbid, which a lot of politicians are proposing right now. Let's see. So I see a question here. The thin it all mentality is dominating, and my message and scientists are not getting through enough. How can we amplify the things that I'm saying? I agree with it all. Is there legislation we can support? Well, first of all, thank you. Appreciate that. I would say right now we need leadership in Congress. There is not a bill that will really accomplish the things that we need right now, but we need it. We need someone to step up in Congress and introduce legislation to fully protect federal public lands from commercial logging, and also expand protected public lands and acquire more forest lands. We need that. We do not have that right now. And I think what we need is for activists, for organizations to start speaking out and reaching out to members of Congress and asking them to protect our forests and opposing members of Congress that are proposing to increase logging. We also need just to increase the visibility for this issue. Get involved, write letters to the editor, to the local paper, write op-eds to the local paper about these issues. Challenge the myths that are being promoted by the logging industry and the Forest Service. And of course, feel free to reach out to me. I'm happy to provide information anytime to people, anytime that they like. In fact, I'm going to type my email address in the chat. So if folks want to reach out directly, feel free. Let's see. Someone asked, can I meet personally with Tom Vilsack? Sorry about that. Someone asked, can I meet personally with Tom Vilsack? No, I have not met with him. I'd be happy to meet with him, but honestly, at this point, I don't think a private meeting with Tom Vilsack is the answer. I think he's pretty committed to a pro-logging agenda. He's the agriculture secretary in the Biden administration right now. He has been promoting a quadrupling of logging levels on national forests based on all of the myths that I just talked about, and claiming that's going to save us from fire and that somehow that's a climate resilience solution. Really, it's a new type of climate change denial, because he's denying the science of climate change, denying the role of logging in increasing carbon emissions, and denying the science that's saying logging does not stop forest fires. I think at this point we need public pressure on the Biden administration, and especially directed at Tom Vilsack, to push back on these myths and these proposals. Someone asked about solutions. Yeah, the solution is we need to get the federal land management agencies out of the commercial logging business, and we need activists to push to really promote that and advocate it. That's been the Sierra Club's policy for 25 years now, and we really need action on that at this point. It dovetails nicely with the 30 by 30 campaign as well. So it's a key aspect of climate solutions. And what we really need is to push for someone in Congress to pick up the ball and demonstrate leadership. That's the solution. We need to move forward with that. And also have subsidies for tree-free alternatives for building materials and paper. Let's see. So one question was about some burn forests not regenerating after fires. Interesting. That's a common notion. I just published a paper a couple months ago with my co-author Tanya Chi, and we looked at this question because a lot of people were confused, including a lot of politicians. They think, well, there's some papers out there that say there's a certain portion of the high-intensity fire patches that's not regenerating. And they wonder, because other papers are saying there's lots of regeneration. And so they think, well, maybe there's a conflict in the science. What am I to believe? It turns out there's not really a conflict in the science. The problem is that there's a whole series of papers, mostly funded by the Forest Service, that had a key methodological flaw. Their field plots were far too small. That's what we found in the Hanson and Chi 2021 paper. In other words, when you have field plots in the forest, in these fires that are tiny, you're gonna have a lot of zeros. And then what they're reporting is, oh, well, look, 43% of our plots in the high intensity fire patches had no conifer regeneration. And therefore 43% of the area that burned at high intensity is deforested, is not regenerating, is type converted. And it turns out that's not true at all. Oftentimes these areas are areas that have 200-300 conifer seedlings and saplings per acre that are naturally regenerating. But if your field plots are the size of a small kitchen, you're going to end up with a lot of zeros and create a very misleading impression for the public and for policymakers. So we pointed out that methodological flaw, and hopefully we'll get better science in the future. But I've been doing field research in these big fires and in large high intensity fire patches for over 20 years now. I have not found a single acre that was deforested and where the forest isn't regenerating and there's just bare ground. That's a myth. The only places that I've ever found like that are areas that have been post-fire logged, which really can deforest an area and type convert it. Let's see. Someone asked, how can the Sierra Club help? Well, again, groups and chapters can get involved. It is the Sierra Club's policy that we support and advocate full protection for federal public lands from commercial logging. And so we can all advocate this. We're a volunteer-led organization, and we have the freedom and the power to do this and we need to start banding together across the country and pushing for this, because that's the only way we're going to turn the corner on climate change. Let's see. Someone asked, I mentioned Oregon's 2 senators, but where are other House members? Where are our House members? In Oregon, it's a mixed bag, so some House members in Oregon are really bad on this, and some are actually pretty decent, so it really depends on the member of Congress. But mostly we need a lot of people to get involved and meet with their members of Congress, congressional staff, and just say, listen, we want you to protect our forests. They need to hear from groups, especially Sierra Club, and they need to hear from us a lot, and they need to see that there's visibility being generated in the newspapers, in Oregonian, Register Guard, for example, and the Bend paper. We need this kind of visibility. Let's see. One question again about post-fire regrowth. Are trees not regenerating because they're reburning before trees can grow? It's interesting. There's been research on this reburn idea, that if an area burns at high intensity, and then it reburns again at high intensity, within 10, 15, 20 years, that the idea is, well, then it really will type convert and it won't regenerate. Interestingly, that doesn't happen there either. There was great work on this done after the Biscuit Fire of 2002 by Daniel Donato and Bev Law and numerous others. And they found that the areas that burned at high intensity in earlier fires and then reburned at high intensity in the Biscuit Fire actually regenerated wonderfully. Lots of conifer regeneration, non-conifer trees, shrubs, wonderful, vigorous forest regeneration. And so the reburn didn't stop the regeneration. Interestingly, what I found in my paper I just published on this with Tanya Chi is that it didn't matter how far you were from the nearest live tree, because birds and small mammals are bringing seeds all over the forest. So even if you're too far from a tree for the wind to disperse the seeds, the birds and small mammals will do it. And the forests are regenerating even 1,000 feet or more from the nearest live tree after fire. All right, it looks like, so I think I've gotten to most of the questions, but I'd certainly be happy to answer a couple more if people have them. I appreciate everyone taking the time and appreciate your patience with the background noise. I apologize again for that. I think you're on, I couldn't hear you, Gretchen. You might be on mute.
Okay. Yeah, I was wondering, can we access some of your papers? Could we do that on the John Muir Project website, or where would we find some of the papers that you're referring to about your research?
Sure. So you can find some of my research and research of some colleagues on the John Muir Project's website. We have a science page, and a lot of the studies are there for free. There's a link to them. And others, certainly some of the more recent ones, just to email me. I'd be happy to email you a PDF. I'd also be happy to send along fact sheets where I address some of these questions in kind of bite-sized chunks, but have citations to peer-reviewed scientific studies on this. Also, I saw someone just put in the chat a question, how about forest protection as part of the infrastructure bill? Well, I think that's a great idea. Right now, unfortunately, the proposals are to increase logging and to try to shoehorn that into the infrastructure bill. So I think we need to oppose those proposals. There's one from Senator Bennett right now, a conservative Democrat from Colorado, that's proposing a massive increase in logging and increase in subsidies for logging. But what we should have and what we need is our members of Congress to show leadership and actually include forest protection measures in the infrastructure bill to protect our forests, to reduce logging, to move away from logging, to protect mature and old forests, to stop post-fire logging, to basically move away from all the things that are taking carbon from our forests and putting it into the atmosphere.
Well, as you know, the one of the main arguments for putting it in the infrastructure bill, of course, is jobs. And the logging industry has tremendous influence. And so, it's a nice conjunction of a message that is, again, a myth. But, I do wonder about the jobs part of it. Do you have any comments on that?
I do. Yeah, it's a great question. So a number of folks have looked at this, resource economists, and what they've found is that there are far, far more jobs are created by recreation and tourism on our national forests than by logging. The last estimate was 38 times more jobs are created by recreation and tourism than by logging. And of course, logging undermines the recreation economy. Nobody wants to camp in a clear cut. And in fact, more recent research has been done by Headwaters Economics, a group of PhD resource economists out of Montana. And what they've found is that the western counties, rural counties with the highest percentages of protected public lands, including protected forests, have the lowest unemployment and higher per capita income. So in other words, protected public lands and having a higher percentage of the county in protected status is actually really good for the economy, and it's good for jobs, and it's good for per capita income. Briefly, I saw a question about non-commercial thinning, and I'm really glad you asked that, because not all thinning is commercial. Most of it is, but there are some non-commercial thinning operations where they just remove small trees and usually pile and burn them. And interestingly, those areas, it's really mixed. I'm finding in the research I'm doing right now, I'm expanding my research on the Creek Fire and the Castle Fire, two large fires from the Sierra Nevada last year. And I'm actually finding that the what they call pre-commercial thin, where it's usually like less than 8 inches in diameter is the thinning. And they didn't burn as intensely overall as the commercial thin areas, but they burned more intensely than the forests that had no thinning whatsoever, including really dense forests that hadn't burned in over a century. The non-commercial thin areas burned more intensely than those. And also the non-commercial thin areas burned more intensely than forests that had a lot of dead trees at the time of the fire. So I think the message is this, is that we just need to allow more fire in our forests, but we're not going to basically get what we want with chainsaws and in the forest. I think what we need is more fire, because cutting trees tends to alter the microclimate in ways. And of course, non-commercial thinning is probably not going to do it to the same degree as commercial thinning, but it's not going to give us the result that we want overall. Again, you can always find exceptions. There are areas that were pre-commercially thinned that burn at low intensity. There's plenty of them. I've found them, but on balance, they often burn at the same or higher intensities. Someone's asking for citations. Yeah, so I mean, there's a lot. I have citations in my slides, but I'd be happy to provide. Tell you what I'll do. I'm going to send along to Gretchen a couple of key fact sheets that have many different citations on the key questions that I addressed today, and then please feel free, Gretchen, just to distribute that to folks who joined today and to any others who are interested. And then again, people can reach out to me and ask me if they want more information. I'm always happy to send along additional studies.
I think that what the Juniper Group is going to do is to send our senators copies of your book, and probably some of our reps too, to maybe get the full scoop.
Well, great. I mean, I think hopefully at least that spurs a conversation, an honest conversation about these things. Because again, what Senator Wyden and Senator Merkley and some of the House Democrats in Oregon and elsewhere, the message that they're promoting to their constituents is, if we just do a lot more thinning, basically a whole lot more chainsaws and bulldozers from the forest and removing trees, if we just remove a lot more trees from the forest, it's going to consistently and reliably curb fires, stop fires, reduce fire intensity. And I can tell you unequivocally that is not true. Again, you can always find a thinned area that burned at lower intensity. There's lots of examples of that. But the problem is that we have the Forest Service, which is of course in the commercial logging business, and the logging industry, and a lot of politicians pointing to those exceptions, those places where thinned areas do burn at lower intensity, and oftentimes focusing on those areas and doing scientific studies, and ignoring all the thinned areas over the ridge that burned at higher intensity and were more numerous. And that's the problem, is that when we look at this, when we pull back and we look at this issue from a broader, unbiased landscape scale, what we're finding is that on balance, the thinned areas are typically burning at higher intensity. And of course, it's completely shooting ourselves in the foot from a climate change standpoint, because thinning is removing oftentimes 30, 40, 50% of the carbon, above ground carbon from the forest, most of which goes into the atmosphere almost immediately. So it's not a climate solution.
Well, I think the problem is that people have an instinctive fear of fire. And so they want a solution that is going to keep them free from fire rather than understanding about the home hardening and that sort of thing.
Yeah, I think that point is well taken. And I think one thing that I hope the Smokescreen book will do, and a lot of the content, and of course I have hundreds, I wrote the book for a non-scientist audience, but I have hundreds of peer-reviewed studies cited in the endnotes in the book for people who want to get more into the details. But one of the things I hope is that people understand is that fire is doing really important and typically beneficial ecological work out in the forests. But it is catastrophic and destructive if it burns a home down, or if someone is hurt, or if they lose their lives in a fire. And we're seeing that increasingly in towns in the West, in Oregon and California and elsewhere. The thing is, and this is what I talk about in the book extensively, that is almost entirely preventable. But in order to prevent that, we're going to have to shift our focus. We're going to have to move away from backcountry logging and fire suppression and focus our resources, focus our attention on homes and communities and protecting them from wildfire. And when that's done, when that's where the focus is, what we're seeing is an example after example, over 95%, over 99% of homes survive, and people get out safely and then can return to their homes. But when we see examples where the approach is more logging, more commercial thinning, more post-fire logging in the forests, far from homes, based on this idea that that'll somehow serve as a fuel break or stop fire from reaching the communities, people have a dangerous false sense of security, and they're not doing the defensible space pruning. They're not doing the home hardening work to make their homes fire safe. And then we see tragedy, and we see lives lost, and we see entire neighborhoods being devastated by fire. But again, it's preventable. It's almost entirely preventable. Well, we just have to shift our direction.
Great. Were there any other questions that you saw in the chat, Chad?
I think that's everything. And I know that folks have already committed an hour to this, and I really appreciate that.
Yes.
So, and they're probably getting tired of the background noise. And again, my sincere apologies for that, especially the Harley Davidson that drove by about 10 minutes ago.
Okay. Well, I wanted to let everybody know that I have been recording, and I can make a link to that. I'm going to try to set up a YouTube page for Sierra Club locally and put it on that so that they can.
Thanks, everyone.
Yeah.
Well, thank you so much, everyone, for taking the time this evening to hear about this stuff, and for all the great questions. Just wonderful. I see some familiar faces and names, so great to see you all. And again, feel free to reach out, and I'll send some fact sheets to Gretchen. And thanks again, everyone. Thank you
so much. This is so beneficial and helpful to all of us. Thank you so much.
My pleasure.
Very generous.
Bye.
Bye.